So there are two directions of the scheduling, which include downlink scheduling and uplink scheduling. For downlink scheduling, downlink scheduling means the input B has to calculate and decide how will the user share the PD-RCH resource. So the user has to feedback CQI because CQI reviews CQI indicates the downlink condition. So user feedback CQI, and the user also has to feedback the HARQ feedback, and the QoS parameters is sent by the core network to the eNodeB regarding the ERAP to be set up and the UE capability. So based on all of this information, the downlink scheduler decide which user is having higher priority or which ERAP is having higher priority, followed by which modulation and coding scheme to be used. This is very much dependent on the CQI as well, and also the transport block size, which is related to the GBR and AMBR, and eventually to map to how many numbers of the resource block. So the user will be selected, number of the resource block will be determined, and with the modulation and coding scheme or MIMO scheme. In terms of the priority, let's have a look on the priority here. The common control information, including paging messages and SIP, are with highest scheduling priority. So paging messages and SIP are with highest scheduling priority, followed by VoLTE traffic and UE level of the signaling, which is the dedicated signaling, followed by the user plane of retransmission data, and eventually the initial transmission new data of user plane. So we can see that common control information are with the highest priority, and new data, new traffic are with the lowest priority as compared to retransmission. So retransmission data is having higher priority than a new data. So the common control information include SIPs, paging, and the random access response. So dedicated control, we have seen that earlier, which is the UE level signaling. That is usually for RRC connection, RRC signaling, where the format could be either SRB0, SRB1, and SRB2. So in general, control information is having higher priority compared to user plane, because user plane, that is traffic, the control plane has to be with higher priority because user has to decode the control information first in order to decode the user plane. So at the same time, control information is also using a lower phase of modulation coding scheme to ensure the quality. IMS signaling, which is the signaling for VoLTE, is a special user plane data which has the same priority with SRB1 and SRB2. And as to compare for the user plane, we have seen that earlier that for user plane, which is traffic, retransmission is having higher priority compared to initial transmission. So retransmission adopts synchronized HARQ process with the minimal delay is 8 milliseconds, maximum delay is 8 plus a timer millisecond. So based on the waiting time, the inner bit determines the priority for retransmission, means those data which has been waiting for the longest time in the buffer of the retransmission, they are having highest priority. So just remember that eNodeB always try to finish off the data which has been sent and now pending for retransmission, then they are all with higher priority. As for modulation and coding scheme, and also the resource allocation, they are using exactly the same mechanism as initial transmission. So the eNodeB stops scheduling when the retransmission for all users are completed or the resources have been allocated. So after the sending of retransmission, then we're looking at the new data, which is the initial transmission. So for initial transmission, then the eNodeB consider the barrier type of the ERAP, which it could be GBR barrier or non-GBR barrier. GBR stands for guaranteed bit rate, where the CQI will be considered, packet delay budget will be considered, and the guaranteed bit rate will be considered. As for non-GBR barrier, then CQI and AMBR are the most important factors in determining the scheduling priority. A minimum GBR could be defined in the system, means we can actually define a minimum value to safeguard the lowest bit rate of a non-GBR barrier. So this is for a priority calculation after the users has been selected. The users to be selected are just all of the users which are qualified for scheduling. So the users who are not qualified to participate in scheduling will be filtered out. So what kind of users are going to be removed? Which are the users who are now in measurement gap, means the user are now measuring the signal strength of another frequency, or the users are now in DRX mode, means the user has been turned off the reception, or the user is now out of synchronization. Then the users will be filtered out, and for the remaining users, the priority are all dependent on the GBR barrier setting and non-GBR barrier setting. Then for modulation and coding scheme selection, LTE is adopting adaptive modulation coding mechanism, where the init B consider the CQI of the user and the transport block size of the data, then to select an appropriate modulation coding scheme. Then once the users and has been selected and priority has been set with the modulation and coding scheme, then the resource has to be decided, where the user could be sending the CQI, or it could be subband CQI or wideband CQI. Then this is going to affect the resource block which is allocated for the user. There are two types of resource block allocation. The first one is called frequency selective, and the second one is called non-frequency diversity scheduling. So frequency selective scheduling means the resource block allocated for the user might not be continuous. So it could be not continuous of the resource block assigned for the user, means the resource block assigned for the user, they could occupy a different segment of the frequency band. That requires the user to report subband CQI. If we're using frequency diversity scheduling, then the resource block assigned for the user is continuous, and the wideband CQI will be required to be reported by the user. So as for the init B to calculate the scheduling priority for all users, then it depends on the scheduling algorithm used. There are 4 available scheduling algorithms, which the first one is called maximum C over I. Maximum C over I only consider the CQI, which is the channel quality reported by the user. So the user which has reported a better CQI value, they are having higher priority in scheduling. So this could be used if we need the system, we need to verify the maximum system throughput, then we can actually turn on maximum C over I. The second scheduling strategy is called round robin, where round robin simply arrange the scheduling priority based on a first in, first out concept, which each user is having equal priority or equal opportunity to be scheduled. So this is only applicable or suitable to be used if we wish to verify the upper limit of the scheduling fairness. So round robin is considered the most fair scheduling algorithm, but it does not really help to verify a system throughput as the peak throughput. So round robin is seldom used actually. Proportional fair scheduling algorithm consider the current service rate and the channel quality. So the user with a small ratio between the service rate and the channel quality, it has a higher priority in the scheduling. In other words, we call it capital R divided by a small r, where capital R stands for the theoretical bit rate which the user is supposed to achieve according to the CQI, that's capital R, divided by the small r, where the small r is the current service rate. So if the user is with a smaller ratio between these two, then they are having higher priority. So this is used if we wish to verify the system throughput and the system fairness. Enhanced proportional fair is the most commonly used algorithm, where the system rate, the small r, is considered, channel quality, which is the capital R, UE capability, and the GBR or AMBR, and the packet delay budget. All of these parameters which is within the QoS requirement, they are all considered. And priority has been integrated with the service rate, UE category, QoS, and CQI. So enhanced proportional fair is the so far most comprehensive scheduling algorithm used in LTE. Then we're going to have a look on the formula or the equation for the priority calculation. So depending if this is for GBR service scheduling, means the guaranteed bit rate which has been set in the 3GPP has to be followed. So the priority of the GBR services depending on the switch. So if we have turned on the MBR control switch, if we have turned off the downlink MBR control switch, means the inner B always prefer to guarantee the GBR services. So then the priority of a GBR services is calculated based on the following formula, where the priority of the GBR base barrier, it depends on the channel quality, which is the CQI reported by the user, and the packet delay budget. So if the user is having higher CQI and the user has a smaller packet delay budget, so the user cannot, this GBR service has a small budget for delay, then the user is having higher priority. As to compare to non-GBR service scheduling. So for non-GBR service scheduling means we do not really guarantee the minimum bit rate of this service. So the priority of this barrier is determined by EFF stands for the CQI again. So again, we are looking at the CQI, which is reported by the user, to the factor of the capacity adjustment factor, alpha. So we're going to look at the alpha value, where the alpha could be 1 or greater than 1, and etc. Then we can see how the alpha is going to affect the influence of the CQI. So we can see that if the alpha value is greater than 1, then we are considering the effect of the CQI more, as to compare if we adjust the alpha factor to be 1 or smaller than 1, then the effect of the CQI is slightly less in terms of the scheduling priority. So this is the CQI with the alpha factor divided by a small r, which is the historical number of the transmitted bits for the user, means the historical service rate. So multiply with the scheduling priority, which is corresponding to different QCI, which this value is going to be set in the system. We are going to set to affect, or we are going to determine the scheduling priority for different QCI, and this setting is going to affect the scheduling priority of non-GBR barrier. Then another factor, that is the delay. So again, we are going to look at the delay, where the indicates the delay for the services. So if the user has been If this particular packet data has been waiting in the buffer for longer time, then the packet is going to have a higher scheduling priority.